Hi students, welcome to another video of Smartly Learn. In this video too, we are going to continue to see about chain rule and how this gets implemented in inside a UV method of differentiation. Let us take a simple input function e power x 1 minus 3x the whole power 4. So I'm going to treat this as a UV function. So here the u is going to be e power x. The 1 minus 3x the whole power 4 is going to be treated as v. So let us calculate the u and u dash, the v is v dash. So u is equal to e power x, which means u dash is also equal to e power x. Now let us calculate the v's, which is 1 minus 3x the whole power 4. So v dash is going to be, here is where I apply the chain rule. Treat 1 minus 3x as t. So this looks like t power 4. So on differentiation, it is 4 into t cube. So replace the t with 1 minus 3x the whole power 3 followed by differentiation of 1 minus 3x. So d by dx of 1 minus 3x. So here is where I differentiate. 1 is going to be 0. Differentiation of minus 3x is simply minus 3. So carry over the answer here. So this is minus 3 into 4 minus 12. 1 minus 3x the whole cube. Now you have got the u's and the v's, the u dash and the v dash. Let's write the final differentiation. So if I treat this input function as y, then y dash is equal to u v dash, which means minus 12 e power x into 1 minus 3x the whole cube. I have taken the u, which is the e power x, and multiplied with v dash. Next I have to do is add to the next term, which is v u dash. So this is going to be another e power x 1 minus 3x the whole power 4. Here I'm going to take the common factors from these expressions outside, which means e power x 1 minus 3x the whole cube. Now open bracket. Here what is left is 1 minus 3x. In here it is just a minus 12 that is left. Now you can simplify this. This is equal to e power x 1 minus 3x the whole cube. This is minus 3x minus 11. I can also take the minus sign outside. So minus e power x 1 minus 3x the whole cube into 3x plus 11. This is the simplification of this expression so that you write everything nicely in the product format. Now let us take one more input function, but this time I'm going to introduce the chain rule inside a u by v method. Let us take the input function. So the input function here is going to be cos 3x divided by x power 4. So I'm going to apply the u by v rule, and in part of the differentiation, let us see how the chain rule comes in. So the u here is going to be equal to cos 3x because the numerator is always the u. The v is going to be the denominator, in this case the x power 4. Calculating v dash is very easy. So let me finish that first. V dash is simply 4x cube. Now to calculate u dash is where we are going to apply the chain rule. Treat the 3x as t. So it looks like cos t. Differentiation of cos t is minus sine t. So minus sine 3x followed by differentiation of a 3x, which is 3. Now I can beautify this and write this as minus 3 sine 3x. Now what do we know is the formula for u by v method? It is going to be v u dash minus u v dash by v square. Remember, the first differentiation that you write here is going to be for the numerator and here will be for the denominator. Now let's substitute all the values that we know of. So this is minus 3x power 4 sine 3x minus 4x cube cos 3x. I've just written the VU dash minus the UV dash divided by V square, which is x power 4 the whole square. Now let's simplify this. So this is going to be minus, I'm taking the x cube common outside. So this is 3x sine x plus 4 cos 3x divided by x power 8. You can cancel this x cube with x power 8 and write this in the even simpler form of minus 3 times x sine x plus 4 cos 3x divided by x power 5. I've just removed this x power 3's and x power 8 and simplified that with a denominator. So like this, chain rule becomes a part of UV or U by V method. In the next video, I'm going to show chain rule getting applied on multiple terms. Please extend your support to me by subscribing to my channel Smartly Learn. You can also reach out to me through my website www.smartlylearn.in for more practice worksheets. Thank you. See you in the next video. Bye.